Hey, everybody, this is Miss Eisencraft, and I am here to go over Unit 4, Lesson 8, Practice Problems. This comes to you from me, but it is from your book, page 193. Okay. All right, so this first one is kind of interesting because it starts off linear. So it's a function, but it's linear. And also it goes through the origin. We talked about this a lot in middle school, direct variation. So it's asking you, hey, this graph is showing the distance D traveled by two cars A and car B over time T. Okay, so this looks like it's time across the bottom and distance across the side. Excuse my cat. My cat would like to know what's going on. Okay, distance is measured in miles and time is measured in hours. Which car traveled slower? So there's a couple ways to see that. Since they both have the same starting point, you can, and they're both straight lines, you can just look at the steepness of a line, right? If it's more steep, that would indicate that it's traveling more distance in less amount of time. And less steep would be slower, that it's taking longer to travel the same amount of time. So just based on steepness, you could say, okay, I'm going to say graph A. Okay, it's less steep. And in this situation, that would mean slower, right? Another way is because it's direct variation, you can actually, it starts at the origin, you can look at some points of comparison. So like, let's look at a nice spot on the graph. I noticed this one here, like car A is traveling 150 miles in 4 hours. Okay, and car B, it's only taking 3 hours, excuse me, to go that 150 miles. So if you can travel the same amount in less time, you are going faster. So that's another way to compare it, okay? You could even do miles per hour by dividing, and that's also nice. Just might as well talk about it. Car A is 150 divided by 4, and car B is 150 miles divided by 3. The reason why you can just divide the ordered pair is because it does start at 0, 0. That doesn't always work. So you would see car B is going 50 miles per hour. I think car A is like 37.5 miles per hour. So that's another kind of more specific way to do it. All right. A is slower. That's the answer. Okay, here we're going to match the descriptions with the graph. So all of these are showing the volume, the amount of water in a water tank as a function of time. So I'm going to first, the side thing is measuring volume, how much water is in a tank. And then we're measuring time. And it doesn't tell you like if it's seconds or minutes, but as you read through here, it'll start to make more sense. So we're going to look for clues, okay? If you are low, if the graph is low on this side axis here, that would mean there's no water. So down here would be empty, up here would be full. So it looks like graph 1 is representing a full tank or starting with a full tank. Graph 2, 3, and 4 are all starting at time 0 with an empty tank, okay? So for A, an empty tank, this word empty, it's got to be one of these three, is filled at a constant rate. So a constant rate would indicate a straight line, but it's being filled, so you're getting more water as time goes on, but it's constant, so it's going to be a straight line going up for 3 minutes. Then it is emptied, so then the volume is going to go back down. So we're looking for a graph that starts low, goes up, goes back down. That looks like graph 3 is the only one that does that. So I'm just going to put in, I think the easiest way is do A. Okay. Graph B, a full tank. Well, there's only one of these that starts full. Okay, so a full tank means at the beginning you're starting with it full. So it's going to be drained, and then we're going to refill it. Sounds like a waste of water to me. Okay. There we go. That's graph B. Okay. A 2,000, does that even matter? No, not really. A 2,000-gallon water tank starts out empty, okay? It's being filled for 5 hours. So as we move forward, it's being going up, 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 and it says it's being filled for 5 hours slowly at first and then faster later. And that again is the steepness of the line. So being filled, kind of slow, and then faster. Okay, so it's increasing more rapidly. That looks like C. And lastly, D. Let's make sure that works. An empty water tank is filled in 50 minutes. Okay, so right, again, the specifics don't necessarily matter. It matches the story. Then a dog jumps in. And when a dog jumps in, it looks like splashing around and displacing the water out, like all the water is going out. And then they have to refill it. Here we go. So graphs are telling a story of a relationship of two variables. All right, let's keep going. Last one. So now we're going to try to look at a story and then make a graph and not get too hung up on specific numbers, but in general, what does a line going up mean? What does a line across mean? Things like that. Okay. And what do the intercepts mean? So Claire describes her morning at school yesterday. Doesn't that sound nice going back to school, maybe? Okay. So I entered the school on the first floor. Okay, so we're going to need to know where that is. Let's change it. Then I walked up to the third floor. Then I stayed in my class for an hour. Let's try some other colors. Look at all these colors I have to choose from. Afterwards, I had an hour-long class in the basement. Have I used yellow yet? No. And after that, I went to the ground level and sat outside and had lunch. So there's some connections there I'm going to have to make as well. So at the very beginning, she entered the school on the first floor. So let's take that. I'm going to do the same color. So when her story begins, what an exciting story. She goes to school and she's on the ground floor. Time is at 0 and she's not above ground or below ground. She enters on the main floor. Then she walks up to the third floor. Okay. That's not going to take very much time, right? She walks up to the third floor, 2 flights of stairs. And I'm going to kind of make this steep because I'm going to have to show an hour-long class. And an hour-long class relative to how long it would take you to walk up the stairs, we're not going to make those even increments horizontally because that would be a little bit misleading. So you go upstairs, hour-long class. So maybe like 2 minutes walk up the stairs, 60 minutes. Still not even really drawn to scale. Oh, wait, what color was I supposed to do that? Stayed in my class. That should be green. Yeah. There's her staying in her class. Time is going forward, right? Even though it doesn't feel like it in class. Time is going forward and you're not going up any further or down. You're sitting in class. Okay. Then you have to go to the basement. So they don't really talk about the connection there, but let's go ahead. If you have to class in the basement, you need to get there. So it'll probably take you about 2 minutes, 1 minute, 2 minutes to walk downstairs. Okay. Then you have an hour-long class down there. I made that a rainbow. How fun. Oh my gosh. Come on, Miss Eisencraft. Okay, there's your hour-long class in the basement. And then after that, she goes back to the ground level to eat lunch outside. Isn't really get to walk up to the ground level. Okay. And then she ate outside. So that idea, and again, that's not her walking forward. The forward motion on the graph is time, right? And so we're kind of thinking of these as chunks of time and what's the story. The up and down does literally look like it would in real life because that is the height, and height does go up and down. So that's kind of nice because that works out. It's important if you're ever interpreting a graph, it's always nice to look at what the horizontal means with the variables, and then the whole graph can kind of make more sense. All right. Hope that makes sense. Good luck. Goodbye.